Review for Geometry, Topic 7, Exam, Section 2. Section 2 has 12 questions. Let's take a look at them. Okay, question 1. Determine which of the transformations applied to circle A could be used to prove circle A is similar to circle C. Select yes or no for each transformations. So we're starting with circle A and we're trying to see which transformations listed below are going to change circle A into circle C. Now, if you look at all the possible answers, they all involve a translation first and then a dilation. So first of all, let's look at the translation. We could use the center of the circle to know what is the correct translation. So first of all, you could go to the left 1, 2, 3, 4, 5, 6, 7 units to the left. Okay, 7 to the left. And then here we're at positive 4. We will go down 1, 2, 3, 4, 5, 6 units down. Okay, so 7 left and 6 down. If you look at the possible answers, there's only one odd one, which is this one, which is wrong. So I can eliminate that answer because all three of the other answers say 7 left and 6 down, or 6 down and 7 left, which is the same thing. All right, so now we got to check on the dilation. Okay, so the way you should check the dilation is, let's compare the radius of the big circle to the radius of the small circle. So if you look at the radius of the big circle, let's pick an easy radius. For example, if we go like that, it's easy to count. This radius is 1, 2, 3. So the radius is 3, and for circle C, the radius is just 1. Okay, so 3 multiplied by how much will give me 1? Obviously, 3 divided by 3 equals 1. But if I gotta write it as multiplication, it would be 3 times 1/3 would give you 1. And the reason why is because 3 times 1/3 is 3 over 3. Is the same as 3 divided by 3. So it would give you 1. All right, so the correct answer would be, the first one is correct because the translation is correct and you're doing a dilation of 1/3. That means that you're multiplying it by a scale factor of 1/3. All right, the second one is wrong because the scale factor of 3 is incorrect. Okay, now notice there's another question, there's another answer that's correct. All right, this answer says the same thing as this answer. It's just that the translation is a different order. Why did I put that in the review? I wonder why I would bother putting that in the review. All right, so there's 2 answers that are correct. And the last one is wrong because both the translation as well as the dilation are wrong. All right, moving on. Number 2A. In circle M below, if the measure of angle AMC is equal to 8x plus 12 degrees. Let me write that here. 8x plus 12 degrees. And the measure of angle ABC equals 5x minus 3 degrees. 5x minus 3 degrees. That's this angle right here. Okay, what is the measure of angle ABC? Okay, so what we got to realize on this one is that the relationship that exists between this arc and these two angles. Okay, first of all, M is the center of the circle. How do I know that? Because it says here circle M. So M is the center. That means that this is a central angle. If this is a central angle, that means that the measure of this arc is also 8x plus 12 degrees. Okay? And if the measure of this arc is 8x plus 12 degrees, the relationship that exists between this arc and this inscribed angle is that this inscribed angle has to equal half of whatever this arc is. Or another way to say it is that this inscribed angle has to equal, or wait, let me say that better. Another way to say it is that this arc equals 2 times this inscribed angle. All right, so if you have no idea what I'm talking about, this is what I'm talking about right here. Whenever you have an inscribed angle, let me put an easy number. If this arc is 80 degrees, this angle has to be 40 degrees. Okay, that's the relationship I'm talking about. All right, those are just two random numbers that I put there. So if this arc is 80 degrees, this angle has to be 40 degrees. So I could either write that two different ways. I could write 2 times 40 equals 80, or I could write 40 equals 1/2 of 80. Those are two different ways of expressing the same thing. Okay, I'm gonna use those to solve this question right now. Okay, así que esta es la relación que estoy usando. Aquí me dice que este es círculo M. Eso me dice que M es el centro del círculo. Si M es el centro, esto quiere decir que este es un ángulo central. Si este es el ángulo central, eso quiere decir que este arco tiene la misma medida que el ángulo central. Ok, así que así es como encontré que este arco mide también 8x más 12. Y la relación que existe entre este arco y este ángulo es que este arco es el doble de este ángulo, o este ángulo es la mitad de este arco. Se puede expresar esa relación de estas dos maneras. All right, so how would I do it? I think the easiest way is to write it out that angle ABC, if you multiply angle ABC by 2, you get this arc. So let me write it this way. That way I don't have a fraction. That's the way I would recommend that you do it. 2 times 5x minus 3 will equal 8x plus 12. Now I would just distribute. So I'd have 10x minus 6 equals 8x plus 12. From here, we've done this a million times. I could just move 8x to the left and the minus 6 to the right. So 2x is going to equal 18. So x equals 9. But that was not the question. The question was, what is the measure of angle ABC? So now I got to substitute the 9 right here where it says 5x minus 3. So the measure of angle ABC is going to equal 5 times 9 minus 3. So the measure of angle ABC is going to equal 45 minus 3, which is 42 degrees. Okay? And I have the explanation typed out nicely here. All right, and I also have a 2B, a second example with different numbers, in case you want to practice or look at another example. Aquí tengo otro ejemplo con diferentes números. If you want to practice it later, you do it the same way. Se hace de la misma manera. Question 3A. What is the approximate area of the shaded sector? So hopefully some of you followed my advice and memorized the formula to find the area of a sector. The formula was you have to do m over 360 times the area of a circle, which is pi r squared. So this is the formula that you have to use. So I'm going to substitute the number of degrees of this central angle where m is. So it's going to become 124 over 360 times pi times 5 to the second power. Okay, now when you work that out in a calculator and substitute 3.14 for pi, your answer is going to be 27 square units. Okay, so in your calculator you would do 25 times 124, or I'm sorry, 25 times 3.14 times 124 equals, divided by 360 equals, and you'll get, when you round it, you'll get 27 square units. All right, moving on. And here's another example in case you want to practice with another example. Aquí hay otro ejemplo similar, simplemente con diferentes números por si quieren practicar. All right, you're just using that formula and substituting the value. Question 4A, find the value of each variable. This question is extremely simple. You just have to remember that when you have a quadrilateral inscribed in a circle, Okay, and again, inscribed means that all four vertices are on the circle. Then opposite angles are going to be supplementary. All right, so these two angles got to be supplementary. So if this one's 120, that means this one has to be 60 degrees because they got to add up to 180. And then these two angles got to be supplementary. So if this one's 105, this one has to be 75 so that they could add up to 180. Okay, tienen que recordar que cuando tienen un cuadrilátero inscribed dentro de un círculo, los ángulos opuestos tienen que ser suplementarios. La suma te tiene que dar 180. All right, so that one's pretty simple. And here's another example in case anybody needs a second example. Si alguien necesita un segundo ejemplo, you could work that out on your own if you want to practice. There are the correct answers. Okay? All right, moving on to question 5. 5A. Find the measure of angle B if the measure of arc AB equals 140 degrees and the measure of angle A equals 30 degrees. Okay, so the key in this one is remembering that, let me try to draw this here, the relationship that exists between this arc and this angle, which is angle C. All right, this arc is the intercepted arc of angle ACB. All right, and this inscribed angle always has to be half of this arc. Este ángulo siempre tiene que medir la mitad de este arco. So that means that angle C has to be 70 degrees. Once you know that, the rest is easy. Because the question is find the measure of angle B. Remember that when you add up the interior angles of a triangle, it always has to equal 180. 70 plus 30 is 100, so this one has to be 80 degrees. All right, the key is, again, you got to find this one first. Once you find this one, then it's simple. Just subtract 180 minus both of these numbers to get the angle that goes here. Okay? Así que a la vez que encuentran la medida de este ángulo, lo demás es fácil porque ya deben saber que la suma de todos los ángulos interiores de un triángulo te tiene que dar 180. Así que si resto 180 menos estos dos números, me da la medida de este ángulo. All right, and here's another example with the different numbers that you could practice on as well. Aquí hay otro ejemplo. All right, question 6. This one, I would like for everyone to pay attention, even like my top students, because I'm going to give you some good advice. It says, which statement correctly relates the dilation of a circle with its new area? ¿Cuál declaración correctamente enseña la relación entre la dilatación de un círculo y la nueva área? All right, so the reason I want you to pay attention is I want to show you how I would approach this problem. Because a lot of times when you're taking exams or even when you're doing homework, you may encounter a question that you don't know the answer to. But look how you could figure out the answer. Okay, so look at what I'm going to do. First of all, if you look at this, all the answers are talking about dilating a circle about its center by a scale factor of, all right, so the first two, A and B, say the same scale factor, and then answers C and D have a different scale factor. Okay, so that's the first thing I would notice. So they're dilating it by this scale factor, and then they're comparing the new area to the old area. All right, so look, what I'm gonna do is this. Let's make up a problem with easy number, or let me say that better. Let's make up an example with easy numbers. All right, so let's say I have a circle, and what's the easiest radius that I could use? 1. So that's what I mean. Make up an easy example with easy numbers, and we're gonna apply what it says in the answers to this and see which one is correct. And this, like being able to do this, I'm sure a lot of you guys do this already, but this is how even I encounter stuff that I'm not sure, and I could figure it out just by making up an easy example. Before I do it, let me just say that in Spanish. Así que lo que quiero que pongan atención es cómo pueden encontrar la respuesta en una situación donde no están seguros qué es la respuesta. Podemos hacer un ejemplo con números fácil para comparar qué pasa cuando hacemos lo que nos está diciendo en la respuesta. All right, so look, letter A. Let's start with letter A. It says if I dilate the circle by a scale factor of 7/2, okay. So first of all, let's get the area. Let's get the area of this circle. How do you get the area of a circle? By doing pi times radius squared. All right, so the area of this circle would be pi times the radius is 1 to the second power. So the area of this circle is pi. All right, because 1 to the second power is 1 and 1 times pi is pi. So the area of this circle is pi. Just stay with me a second, okay? So if I dilate this circle by a factor of 7/2, I'll get a new circle. And the new circle, the radius is going to be 7/2. Now, what's going to be the area of this new circle? I use the same formula, pi times radius squared. So the area is going to be pi times 7/2 squared. So the area is going to be 49/4 pi. All right, so let's compare this new area to this area. What do I multiply this area by to make it 49/4 pi? All right, what number is here? There's an invisible 1. That came out ugly, sorry. Let me write that better. There's an invisible 1 here. So 1 times what gives me 49/4? 1 times 49/4. So when this circle is dilated by a scale factor of 7/2, its area is multiplied by a scale factor of 2. That's wrong. Because if the area were being multiplied by a scale factor of 2, this would say 2 pi. All right, so letter A is wrong. How about letter B? It says that when I dilate by a scale factor of 7/2, the new area, that's what it means, its area is multiplied by a scale factor of 49/2. No, it's being multiplied by a scale factor of 49/4. So B is wrong as well. Okay, let's check the next one. The next one is talking about dilating by a scale factor of 5/3. I promise you what I'm doing is not difficult. So I highly encourage everybody to pay attention, right? So again, let's make a circle. Let's put the easiest radius possible, which is 1. So the area of this circle is going to be pi times radius squared, which we already went over. That's going to give you area equals, let me write the 1 so that everybody's with me. Even though normally I would not write the 1. All right, so the area of this circle is 1 pi, okay? La área de este círculo es 1 pi. By the way, could I multiply it times pi? Yeah, but why complicate it? Let's just leave it like that to keep it simple. All right, so don't multiply it times pi. Now, if I dilate this circle by a scale factor of 5/3, that means multiply everything by 5/3. The new circle would have a radius of 5/3, right? So let me get the area of this new circle, again, by doing pi times radius squared, because that's the formula for the area of a circle. So I'm going to have pi times 5/3 squared. So the area is going to be 25/9 pi. Now let's compare the new area to the original area. What do you multiply 1 by to get 25/9? You multiply it by a scale factor of 25/9. It says it right here. So C would be the correct answer. When a circle is dilated about its center by a scale factor of 5/3, its area is multiplied by a scale factor of 25/9. Okay, if you're paying attention, I'll give you an even quicker way to do it. You know what's a quicker way to do it? Look at the scale factor. Let me say that better. Look at the scale factor that you're dilating by. The scale factor that you're dilating by is 5/3. So the new area is going to be multiplied by the square of this scale factor, by the square of this scale factor. That's the only, out of the 4 answers, that's the only one that has that. Okay, and I'm just going to throw this out there. Mainly, I'm throwing this out there for the people paying attention that get good grades, right? Make sure you know how to do the process, or make sure that you know one of 2 things. Make sure you either know how to do that process that I just did, or that you understand the relationship I just pointed it out. Let me say that again. that you understand the relationship that I just pointed out, because I purposely disguised this so that the people that aren't paying attention, that are just going to look at this review and look at the answer that kind of looks like, look at the correct answer and try to pick the answer on the test that looks like that one, they're going to get it wrong. All right, so I'm just giving you a heads up because I disguised it to fool the people that are not really looking at the reviews. All right, moving on. So there's the answers, C. But I do want you, especially the top students, make sure you know that technique. When you get a question that you don't know the answer to, you could make up. I do that all the time. Make up your own example. Make sure to use easy numbers and apply the possibilities that are in the answer choices so that you could examine what happens when you do that. I do that a lot of times, believe it or not. And it's really helpful for understanding a question. All right, moving on to number 7. If the center of the circle below is O, what is the measure of angle AOB? Okay, so in this question, look at how I'm going to do it, right? They give us the measure of this inscribed angle. Inscribed means that the vertex is on the circle. Okay, so with this inscribed angle, I could figure out the measure of the arc of its intercepted arc, which by now you should know already. You should know what I'm going to say. Okay, ellos no están dando la medida de este ángulo que tiene el vertex encima del círculo. Así que con esta medida yo puedo encontrar la medida del arco que está interceptando este ángulo. Tiene que ser el doble de este ángulo. It has to be the double of that angle. So that means that this arc is 244. Now that I know that this arc is 244, let me change colors here. That means that a circle, we know a circle is 360. So this remaining arc has to be 360 minus 244. Okay, el arco que falta tiene que ser 360 menos 244, porque sabemos que un círculo mide 360. So when I subtract that, all right, I'm going to get 116. And the final part is, they told us that this is the center of the circle. It says up here, if the center of the circle below is O. Nos están diciendo que el centro del círculo es O. That means that this is the central angle. And the relationship between the central angle and the arc that it intercepts is that the measure of this angle equals the measure of this arc. So that means that this angle has to be 116 also. That's the answer. Okay, la relación que existe es la medida del ángulo central es igual a la medida del arco que está interceptando. Así que si este arco es 116, este ángulo central también mide 116. All right, so that is the answer. Here's another question. I just changed the numbers in case you want to practice and make sure you understand it. Okay, esta pregunta es la misma cosa, simplemente le cambié los números por si alguien quiere practicar o ver un segundo ejemplo. All right, moving on to question 8. All right, question 8 is like the only weird one, like really weird on section 2, okay? I'm going to do my best. I mean, really, it's not that weird, but I mean, I got to explain it, and it's a little difficult for me to explain. I messed up and I put the answer there, but whatever, I'm going to leave it. So, all right, first of all, let me give the short explanation for the people that don't really care about the explanation. All right, the short explanation is, this is the same answer on the test, and I'm giving it to you. I wish we could have a little like lottery so we could guess how many people are still going to get it wrong. I promise you there will be people, more than one or two. All right? So that's the answer on the test. A bunch of people are going to get it wrong, though, because that's the way it is. All right, now, the short explanation. First, let me give the short explanation. The short explanation is, in the question it says, if theta is the radian measure of a central angle of a circle, and r is the radius of the circle, which is the correct derivation of the area A of the sector bounded by the sides of the central angle and the arc it subtends? Yeah, you probably got to read that 2 or 3 times for it to sink in. Okay, but basically, A stands for the, A stands for the sector, the area of the sector. All right, so that capital A is the area of the sector. Okay. Now, let me point out a couple things because I looked at this question for a while to try to figure out the best way to explain it to you guys. First of all, on the left hand side, they're giving us this proportion on the left hand side for all of them. And for every single case, when you solve for A, you get what's on the right. So what I'm saying by pointing that out is that, like, if this were correct, then the right hand side is correct as well. Because what they're doing is this on the right hand side. Like, A is wrong, but let me just show you. A, what they're doing is this. They're saying, they're giving you that. And if you solve this equation for A by moving this to the right and multiplying it, you would get A equals theta 2 pi r over 360. And when you simplify the 2 and the 360, you would get 1 over 180. So you would end up getting this when it's simplified. And my point is, that's what's written here. So mathematically, like if this is correct, mathematically the right-hand side is correct. On the right-hand side, they're just solving for A. Okay, having said that, now, the only relationship that's correct is this one. And more importantly, let's look at the right side of this first. Okay, let's look at the right side of this first. I said that the capital A, it says here, capital A is the area of the sector. Capital A is the area of the sector. Okay, now look right here. When the central angle is in radians, you got to use these formulas, which were not in the book, but they are in the test and they've been in my reviews. Okay, so this formula right here is the same as this formula. It's just written differently, slightly differently. But look, up here I got it written this way, but realize that you could just put 1 times r squared and theta. You just put the r squared and the theta on the top and the 2 on the bottom. And you could also put, like, to make it match up with this one, you could put theta in the front and r squared in the back. But I'm trying to tell you that this formula is the same as this formula. They're just writing it slightly different, but they're both the same. So that's one way that you could remember which is the correct answer. And by the way, these formulas are not given to you on the test. Obviously, you could use my review on the test and see the formula right there, but I'm just telling you, they don't give you the formula on the test. All right, so that's one way to point out which is the correct answer. This answer is this formula for the area of a sector, because that's what they're looking for. I would do that. I would say that that's the best way to approach this problem. Okay, now I could talk about why this is the only relationship that's correct, but to be honest, I could talk about it for like 5 or 10 minutes, and it's not until you guys do some problems involving it that you'll realize it. So I don't want to waste time and make the review longer than I need to, because I think even me, I had to like do a couple. I had to substitute some values and like work it out for it to fully make sense. All right. A quick explanation will be that they're comparing the area of the sector to the area of the entire circle, and they're saying that equals the measure of the central angle in radians to the measure of the entire circle in radians, which would be 2 pi. All right, and I'll leave it at that. Okay, so again, the easiest way to approach this problem is that the correct answer is giving you the formula for the area of a sector written when the central angle is in radians. You just got to realize that it's written slightly different, but it's the same thing. All right, moving on. Question 9a. What is the length of the arc? What is the length of this arc bounded by a central angle POQ? Show your answer in terms of pi. All right, so this one is pretty straightforward. You got to use the formula for arc length that we used in the book, where you replace m with the degrees, with the measure of the central angle in degrees. So it's going to be 40 over 360 times 2 pi r. All right, so if I simplify this fraction by dividing the top and the bottom by 40, I'm going to get 1 over 9 times 2 pi r. Oh, and I'm sorry, r is 9. So 1 over 9 times 18 pi, which is going to equal 18 over 9 pi. 18 divided by 9 is 2. So my answer is 2 pi, because they want you to show your answer in terms of pi. All right, so the answer is 2 pi. There's the work. And I have another example here in case you want to practice another example or see another example. Aquí tengo otro ejemplo. But it's the same thing. I just changed up the numbers. All right, moving on. 10a. What is the equation of a circle? Okay, now we're going to get the last 10, 11, and 12 are all involving circles and the equation of a circle. Okay, los próximos problemas todos son con un círculo y la ecuación de un círculo. So what is the equation of a circle with center 4, 5 that passes through point 8, 5? All right, so look. So I have a circle. Actually, I didn't need to draw the circle for that part. I'm sorry. All right. First of all, if the center is at 4, 5, you should know that that's h and k. Okay, and the formula for the equation of a circle is parentheses x minus h squared plus parentheses y minus k squared equals r squared. So already with that, I know that the first part of my answer is going to be x minus 4 to the second power plus parentheses y minus 5 to the second power. That part is easy. Okay, now for the radius, it's also easy, but in case you don't see how you would do it, look how you could do it. All right, you don't have to draw this; you could just imagine it. All right, so whatever, 4 and 5. So here's my center of my circle at 4, 5. So look at the other point that they give you. Okay, the y coordinate is the same. Okay, so basically they're telling you this. Here's the center, and here's another point that's on the circle at 8, 5. The y coordinate stayed the same. The only thing that changed is the x coordinate. That tells you that the radius is 4 units because the distance from the x coordinate of 4 to the x coordinate of 8 is 4 units. So if the radius is 4, that means right here I'm going to put 4 to the second power, which is going to be 16. So this would be my answer. Con el segundo. All right, guys, sorry about that interruption. Here's the explanation, and hopefully you guys were able to get what I was trying to say on that. All right, so the correct answer is this equation of a circle here. And I also have a second example that you could use as well. It's the same exact concept. All right, so again, the key is just, the first part is easy. The key is just making sure you know how to find the radius. All right. La primera parte es fácil. Lo importante es estar seguro que saben cómo encontrar el radius. Okay, question 11a. Identify the center and the radius of the following equation of a circle. Okay, so this one and the next problem, they involve completing the square. All right, so let's look at it. Okay, they do not give us the equation in the standard form for a circle. We got to put it in that form. So the first thing we got to do is move this constant to the right. All right, the first thing you got to do is move any constants to the right. In other words, any number with no variables, it goes to the right. Okay, lo primero que tenemos que hacer es mover los números que no tienen variable a la derecha, los constantes. Okay, so we'll have that. Okay, now we got to do the process known as completing the square. Okay, where in order to do this process, what you're doing is, let me just change colors a second. You're taking the number in front of x to the first power and the number in front of y to the first power. You're taking that number, dividing it by 2, and squaring it. So I'm taking negative 6 divided by 2 and square it. And this positive 8, I'm going to divide it by 2 and square it. And whatever you add to one side, you got to add to the other side. So on the left side of the equation, I'm adding the numbers in blue, and those same numbers are being added to the right side of the equation. Okay? Así que tenemos que hacer el proceso que se llama completing the square, completando el cuadrado. Y para hacer eso tenemos que coger el número que está al frente de x a la 1 y y a la 1 y dividirlo por 2 y cuadrarlo. Ok, así que negativo 6 dividido por 2 y cuadrado y positivo 8 dividido por 2 y cuadrado. Y lo que le sumo a un lado de la ecuación también se lo tengo que sumar al otro lado de la ecuación. Por eso es que estos números están en azul. All right, so the numbers that are in blue are the new stuff that I'm adding to both sides of the equation. All right, so once you simplify that, you'll have these numbers. And the whole point of doing this process is it's going to allow us, it creates a perfect square here. That it's going to allow us to factor this and get a perfect square. And same thing right here. That's the whole point of doing that. Okay, la razón que hacemos eso es para poder factorizar estas dos expresiones y coger un cuadrado perfecto. Right? Because when I factor them, look what I get. This part factored is x minus 3 times x minus 3. And this part factored is y plus 4 times y plus 4. And that allows me to write it in this form, which is now in the standard form of the equation of a circle. Okay? Eso me deja escribirlo en esta forma, que es la forma standard de la ecuación de un círculo. And now I can identify what's the center and what's the radius of the circle. Ahora eso me deja identificar qué es el centro y qué es el radius del círculo. All right, so there are my answers. All right, and here I have a second example. Same process, just different numbers. So again, if you really want to be sure you understand it, you could always write down the question, because you have two questions here, that you could write them down and practice on your own at home and see and make sure that you know how to get the right answer. Ok, aquí tengo otro ejemplo donde pueden escribir la pregunta en una hoja de papel y practicarlo en la casa para estar seguro que entienden el proceso. All right, so here's the explanation. Same thing, you got to do completing the square. And that allows us to write the equation in the standard form of the equation of a circle and to identify the center and the radius. All right, question 12a. All right, this is exactly the same as what we just did, except for one new twist. And this new twist is on the test. All right, and by the way, this is the last question in my review. All right, so the new twist is this, and again, it's like this on the test. The new twist is that before you begin, you have to realize that look at all the numbers. Look at all the numbers in this equation. Can they all be divided by something to make this equation smaller? The answer is yes. They could all be divided by 2. If you divide all of the coefficients by 2, that'll give you this problem. That's what you got to do before you begin this question. On the test, it's different. It's a different number. But you got to identify, hey, this could be simplified to this equation, which will allow you to do everything that we just did. Because if you leave it in this form, you're not going to be able to do completing the square, and you're not going to be able to do the problem. So the first thing you got to do is simplify the problem by dividing everything by 2, at least in this example. Let me just say that in Spanish real quick. Okay, este ejemplo está imitando cómo está en el examen. En el examen le va a dar una ecuación donde primero que nada se tiene que dar cuenta que pueden simplificar esa ecuación dividiendo, por ejemplo, en este ejemplo todos los coeficientes, todos los números se pueden dividir por 2 para coger esta nueva ecuación. Eso es lo que tengo que hacer para poder hacer el mismo proceso que hice en los otros problemas y poder poner esta ecuación en la forma de la ecuación de un círculo. A la vez que lo dividen por 2, es el mismo proceso que hice en la pregunta número 11. All right, once you get it in this form, it's the same process as what you did in question 11, where first you move the constant to the right. Okay, primero se mueve el constante para la derecha. Okay, and now I'm going to do the completing the square process. Okay, ahora estoy completando el cuadrado. Okay, which allows us to factor perfect squares and write the equation in that form, which allows us to identify the center and the radius. Eso nos deja identificar el centro del círculo y el radius del círculo. All right, here I got 12b, which is the same exact thing. I just changed it up. So real quick, if you look at all these numbers, again, it's different on the test. Look at all these numbers. It should be obvious what you could divide them all by to simplify this equation. Okay, esta es la misma situación pero con diferentes números y debe ser obvio por cuánto se puede dividir todos los coeficientes para hacer la ecuación más chiquito. They could all be divided by 3, obviously. So if you divide all the coefficients by, whoops, that's a mistake. That should say 3. I just caught that. Teacher fail. I didn't catch that in time. hice un error ahí. Si dividen todos los coeficientes por 3, it'll give you this new problem. Okay? And then you just follow the same steps to complete the square. And write the equation in the standard form of the equation of a circle, which allows us to identify the center and the radius. All right, guys, so that's it for section 2 of the review. Make sure to look at all of this before the test, especially section 1. Section 1 has a lot of weird stuff in there that you need to look at ahead of time. All right, guys, don't forget to study, because remember, I'm going to count the test a lot. All right, good luck. Hope you guys have a great rest of your day, and I'll see you guys next class.